Okay, so this video is the first one for chapter 9 on momentum and conservation of momentum. Today we're going to look at just simply what momentum is and how you can determine it by using motion maps and graphs. But first of all, you might be wondering, what is momentum? So there's a little video that I'm going to show you what momentum is.
Momentum is inertia in motion. A lot of momentum means a lot of oomph. An even better way to describe momentum is as the product of mass times velocity. This means that if something is moving, there are two ways to affect its momentum. One, there's the mass. You know, for the same speed, a massive truck has so much more momentum than a mosquito. And two, look at the velocity. A baseball thrown gently by a kid will be easy to catch. That same baseball, thrown at 100 miles per hour, might knock you over. So a tiny bullet at a high speed has a lot of momentum. Wear a bullet vest and it'll still knock you over. An oil tanker creeping along at only a few miles per hour also has a lot of momentum, not by virtue of its speed, but by virtue of its great mass. Because it has so much momentum, so much inertia in motion, the tanker can't just pull into the dock. Rather, it's greeted by powerful tugboats that help to manage its maneuvering. A fast-flying tiny bullet and a creeping massive oil tanker are both difficult to stop. Both have a lot of oomph, that is, a lot of inertia in motion, which you now know to be what we call momentum. Good energy.
All right, so momentum is how easy it is to stop an object from moving, whether it's the truck, the bullet, or the ship as mentioned, or any other object. So, as they mentioned in the video, product of the object's mass and its velocity is defined as the momentum. All right. So this is one of the main equations that we're going to use for this particular unit. Momentum is mass times velocity. Okay. Mass is measured in kilograms, velocity is in meters per second, so momentum is measured in kilograms times meters per second. Okay. And because velocity is a vector, because it has a direction, momentum is going to be a vector quantity as well. All right, so first sample problem here. Determine the momentum of a 10 kilogram object that's traveling at 5 meters per second. So what we know is we're looking for a momentum. We know we have a mass of 10 kilograms. We know we have a velocity of 5 meters per second. We know the equation is momentum is mass times velocity. So we're going to take mass times velocity to get the momentum of 50 kilograms times meters per second. Okay. Next sample problem. How fast is a 20 kilogram object traveling if it has a momentum of 60 kilograms times meters per second? So this time we have the momentum, 60 kilograms times meters per second. We have a mass of 20 kilograms. We're looking for its velocity. So we know the equation again is P equals M times V. Momentum is mass times velocity. So 60 kilograms times meters per second is my momentum, times 20 kilograms times my V. So I need to get V by itself, so I'm going to divide both sides by 20, which is what's shown down here. So 60 kilograms divided by 20 kilograms is actually not 30. It's actually 3 meters per second. There is a typo on this slide. This should be 3 meters per second. 60 divided by 20 is 3, not 30. So there's a couple sample problems on the formative assessment for you to do and help you with the practice. Okay, so going back to what we've looked at in the first unit, we can look at motion maps and motion diagrams to figure out if the momentum of an object is consistent or changing. Okay, so if we look at this first one here, my arrows, or my vectors for velocity and the dots for the cars are going at a constant velocity. So because momentum is mass times velocity, the momentum of the top line is consistent. Because the mass of the car is remaining consistent, the velocity is remaining consistent, so my momentum is constant. on the bottom one, the vectors are getting longer. So because my vectors are getting longer here, my velocity is increasing, so that actually means the bottom car is gaining momentum. Okay. Now, if you think about it the opposite direction, you can do the reverse. If you have a negative, if you're slowing down, and that's a negative change in velocity, you can actually have a negative momentum. You're decreasing momentum, it's actually a negative momentum. So you can use the motion maps to help you determine if the momentum is consistent or changing. Now, also, we can use graphs. Okay, so this is a position versus time graph. And if you remember back to the Unit 1, talked about the fact that the slope of a position versus time graph is velocity. So if I know the mass of an object, and I can figure out the slope of a position versus time graph, I can figure out the momentum of any given spot on the graph, any given motion on this graph. Okay, so we're going to do that for this graph. So if the mass of the object making the graph on the right is 10 kilograms, we can determine the momentum during different areas of motion. And we're going to do that for one on here, and you're going to do the other two on your formative assessment. All right, so the slope of a position versus time graph is the velocity of an object. So if we determine the slope and we know the mass, we can simply multiply those two together to get the momentum. Okay, so we're going to do the time from t equals 6 to t equals 9. All right, so the velocity of the slope is the slope of the line. So change in velocity. So we end at 0, we start at 3. So my change in velocity is negative 3 meters per second. My time is 3 seconds. Okay. Sorry, negative 3 meters. So my velocity is negative 1 meter per second. So my velocity is the slope of my position versus time graph. It's negative 1. So, because I know the velocity is negative 1 and the mass is 10 kilograms, we can determine the momentum. So the momentum is, we don't know the momentum, we know the mass is 10 kilograms, we know the velocity is negative 1 meter per second. So momentum is simply just multiplying the mass times the velocity. So the momentum for t equals 6 to t equals 9 is 10 kilograms times negative 1 meter per second, or negative 10 kilograms times meters per second. On your formative assessment, you're going to need to find the slope of the other two portions, so from 0 to 4 and from 4 to 6, and figure out the slopes of those lines, multiply them by the mass, and then you'll get your momentum based on the graph. Okay, that's the end of this video. Make sure, if you have questions, watch the video again if need be, or ask questions on the bottom of the video, and we will see you in class.